time to play the game again, this time using all the steps together. Pay close attention to how I use my visual anchor to help me remember my steps and my thinking questions. Step 1 is to label the parts in whole. For this problem, my number bond's already created for me, and I'm thinking about red crayons, and blue and red crayons together. Let's label my parts in wholes. Is 9 a part or a whole? Say it out loud. Yes, it's the whole. Why? It's the whole because it represents all the blue and red crayons together, or all the crayons. That must mean 5 is a, yes, 5 is a part. Why is that? Yes, 5 is a part because red crayons only represent a part of the blue and red crayons together. What we don't know is the blue crayons. Step 2 says to solve to find our missing number. I know I can use count up, subtract, count back, or just no. If my missing number represents the blue crayons, what can I do to solve for the blue crayons? Okay, let's try subtract, count back. I know we can start at the whole, take away a part that we know to find the missing part. Get ready, grab 9 and count back 5. 9, 8, 7, 6, 5, 4. I've counted back 5. My answer was 4. So the missing part is, yes, 4. You might have used count up or even just no to help you solve the missing number. That's okay. Any strategy works. Step 3 is to write 4 addition and subtraction number sentences to match my number bond. Because I know that there's going to be 2 addition and 2 subtraction, I've already set up my equations to help me. What are 2 addition equations we could write to help represent our number bond? Say your answers out loud and explain why they work. I heard some friends say we could write 4 plus 5 equals 9 and 5 plus 4 equals 9. Why do these equations work? Yes, these equations work because 4 and 5 are our parts. They represent the blue and red crayons separately. 9 represents the blue and red crayons together, or all the total crayons, which means 9 is our whole. We know that we can put all the parts together to get to our whole. Nice work there. What are 2 subtraction equations we could write to represent our number bond? Say your answers out loud and explain why they work. I heard some friends say we could write 9 minus 5 equals 4. Why does this equation match our number bond? Yes, this equation works because 9 is our whole and 5 is one of our parts. We know if we take away a part from our whole, that gives us our missing part. Ooh, I know, let me try the last one. You guys are so smart that I want to turn. I think we could write 5 minus 4 equals 9. What do you think? I see that many of you disagree with me. A lot of you think that I've made a mistake. What mistake did I make and how can I fix it? Say your answer out loud. Some of you say that we can't write this because 5 and 4 are both parts. 5 minus 4 does not equal 9. 5 minus 4 is 1. So you're telling me that if we subtract a part from a part, we do not get the whole. What can we write instead? Say the equation out loud. That's right. Many of you said I could write 9 minus 4 equals 5 because 9 is our whole. And if we take away one of the parts that we know, we find the other part. Thanks for helping me fix that mistake today, team. As you continue working on your own, make sure that when you write your number sentences, you're thinking, how can I put my parts together to equal my whole? And how can I break up my whole into my parts? Remember to label your parts and your wholes in every equation.